Hello dear friends, welcome to the lecture of ordinary differential equations. In this lecture we shall study equations of first order and of the first degree. In the first lecture, earlier lecture, we have studied how to form a differential equation, or before that we have seen some definition of differential equation, order and degree and types of solutions we have seen, and then to form formation of differential equation, problems on formation of differential equation we have studied in earlier two lectures. Now in this third lecture we are going to study equations of first order and of the first degree. To solve a differential equation needs to integrate it, and this is rather a difficult process than formation of differential equation, because for formation of differential equation we have to differentiate, and to solve differential equation we have to integrate. So integration in comparison to derivative is difficult. So some differential equations the solutions are obtained by analytical method, but there are some differential equations which are not we can't find the solution for the differential equation, and we have to use the approximate methods, which are numerical methods, etc. But here in this ordinary differential equations, or in this chapter, we are studying simple equations of first order and first degree, and some standard forms we shall see in this, which are variable separable form, homogeneous equations, equations reducible to homogeneous form, and exact differential equations. So these main type of differential equations we are going to study in this chapter, and among these the first is variable separable form. So that means we can separate the variables and their differentials, or the equation can be reduced in this form: f1 of x into dx plus f2 of y into dy is equal to 0. So here the variables are entirely in x and differential is of x. f1 function of x only multiplied by differential of x, plus this function of y only and multiplied by differential of y, that is dy. So therefore these are separated, x and y. So that's why it is known as variable separable form. And once it is put in this form, the solution is easily obtained on integration. Simply integrate this plus take the integration on both sides or each term. Integration of this is integral f1 x dx plus integral f2 y dy, and here this c is constant of integration. So that is the variable separable form. Now we shall solve problems on this form. So I have written the 4 problems here. Now we consider the first one. Solution for first problem. Solution 1. This is the given differential equation. So we have to put this equation in this form and then integrate. That is the method. So the given differential equation is we can write first as it dy by dx is equal to, and take this term on the right side, and that there will be negative sign, and we separate the radical sign, under root of 1 minus y square divided by under root of 1 minus x square. Now you see, so we can shift the terms. Dx we can shift on this side, and this term of y we can shift on the side of dy. So that we have to separate it, and that means this is the dx to be shifted on this side. Differentials are separated, variables x and y are separated, and this we write dy divided by under root of 1 minus y square, this term, and is equal to, negative sign is on the right side, this dx is taken on this side, dx, it will be at the numerator. Denominator becomes numerator when we shift the term on the other side, and root of 1 minus x square. Simple arithmetic operation is there, algebraic operation is there. And now this term can be written on the left side, and the sign becomes positive. So it will be dx divided by under root of 1 minus x square plus dy divided by under root 1 minus y square is equal to 0. Now you see this is in this form, separable form. f1, what is f1? 1 upon root of 1 minus x square into dx plus f2 of y, that is what is f2? 1 upon root of 1 minus y square into dy. So thus we have separated the variable. So that is important in this type of examples. So we have to recognize the type and then use the method accordingly. Now on integration, what we shall write the symbol of integration, and then this will be integral dx divided by under root of 1 minus x square plus integral of dy divided by 1 minus y square, and we should write the constant of integration when we integrate. At the step where we integrate, we have to add the constant of integration on either side. We have written the constant on the right side. Now what is integration of this expression? It is a direct formula or standard result. Integration of dx divided by root of 1 minus x square is sine inverse x, and therefore it is sine inverse x. Derivative of sine inverse x is 1 upon root of 1 minus x square, and plus similarly this is sine inverse of y, and this is equal to c. So thus this is the solution. After integration we get a relation between x and y, and that is the solution or general solution. It contains one arbitrary constant and the differential equation is of first order. So order is equal to number of arbitrary constant, then the solution is the general solution. So this is the general solution. And this completes the solution of the first problem. Now we shall consider the second example, second problem. What is here? It is y minus x. The given differential equation is y minus x into dy by dx, etc. So that also we should write in terms of dy by dx. We collect the terms. So we shift this term of dy by dx on that side, and we shift this term of a into y square on the left side, and that I shall write y minus a into y square is equal to this term in product is shifted on this side, y is kept on the same side, and this negative x dy by dx on that side becomes positive, and here the coefficient of dy by dx is a and this is x. So dy by dx I shall write common, and in bracket it will be x plus a. You can easily check this. And now we want to write the separate variable form. For that purpose, dx should these differentials should be at the numerator. So dx we have to shift on this side, it becomes numerator, and where dx is there, the term of x should be shifted. So therefore this implies dx divided by x plus a, shifting these terms, and we shift this term on that side, that will be dy divided by y minus a into y square. And now we have to integrate this. So thus we have obtained the separate variable form, or it may be written on the left side also, or you see that can be written as dx divided by x plus a minus dy divided by, we can take y common, y into bracket, what remains inside the bracket 1 minus ay is equal to 0. Now we have to integrate it, and for that purpose you see there is the direct formula for this. It is log of x plus a, but what about this? How to integrate this? And for this observing this expression, we shall apply the method of partial fractions for this. So, and again if you apply the method of partial fractions, the integration will be in terms of log. So on integration we can write when the integration on the left side is in terms of log, we can take the constant also in terms of log, and that we can write as, or we shall first get the fractions and then we can integrate it. So we shall suppose this as 1. Let 1 upon y into 1 minus ay is equal to partial fractions, and we know these are linear and distinct factors, so therefore there will be two partial fractions, a divided by y plus b divided by 1 minus ay, and we suppose this as a second equation, and from this second we can write the numerators 1, and here taking the LCM as y into 1 minus ay, product of this, the numerator will be, after cross multiplying, a into 1 minus ay, that is 1 minus ay into a plus y into b, and this will be the numerator, and this is the numerator on the left side. Denominators are equal. So thus this is the method we have of partial fractions we know, and we have to find now the values of a and b. To get the values of a and b, we equate their denominators to 0 of these fractions. So put first y is equal to 0. Put y is equal to 0 in 3. We get, now put y is equal to 0 in 3, there is no change in the left side, it is constant, and y 0 means it is 1, and therefore 1 into a, and this is 0. So 1 is equal to a. We get the value of first constant a. Now to get the value of b, we put 1 minus ay is 0. Put further 1 minus ay is equal to 0. That is, what is the value of y from this? Y will be ay is equal to 1, and therefore y is 1 upon a in 3. So what that gives, you see. So that gives, see, these are the values to be put in 3. That is 1 is equal to, and this is 0. So 0 into a is 0, and y is 1 upon a. So that is 1 upon a into b, or therefore b is equal to a. And thus we have to put the values of a and b in second, and then second is to be substituted in 1. So thus putting these values of a and b in 2, and from 1 we can write. Now putting the values of a and b in second, we get from 1, or we get this as, first we can write this. A is which value of a we have obtained? It is 1. A is 1 and b is a, and thus second becomes into, we get, see, this is 2, a is 1 and b is a. So this we have obtained. Now put this expression in 1, so that is here, and putting this in 1, we get, see, what is 1? Dx divided by x plus a plus, and we can write this expression separately, that is 1 upon y plus a upon 1 minus ay. This much is this expression. So 1 over this is the value we are using into dy. So dy is common for the whole expression and is equal to 0. Now integrate. On integration, now see, we can write the symbol of integration and then write the values of integration. And when we write the symbol of integration, so this will be integral of first, integral dx upon x plus a plus integral, it is 1 by y plus a upon 1 minus ay into dy is equal to. So this much is the integration of this and this one. And what is the right side? Right side, we see this is in terms of log, this integration is also in terms of log. Linear term is at the denominator, and therefore the by formula it is in terms of log. So I shall write the constant of integration in terms of log. log of c. And now the value of the integrals are to be written, and that is, this will be log of x plus a plus log of y, and you see this value is again log of 1 minus ay. A is constant, log of 1 minus ay, and it is to be divided by the coefficient of y, that is minus a, or that will be a divided by minus a, which is minus. So this integration is minus log of 1 minus ay. You note this integration of this. Actually a is constant, and that is log of 1 minus ay divided by the coefficient of y, that is minus a. So this a divides out, and that is minus of log of 1 minus ay, and this is log of c. Now we can use laws of logarithm to simplify this, and that will be log of when there is addition, it is log of the product of the terms, and when there is subtraction, it is log of the quotient. So this will be x plus a into y divided by 1 minus a into y by laws of logarithm. Log of x plus log of y is log of x into y. Log of x minus log of y is log of x divided by y. That laws we have used. And now we can eliminate log on both sides. So this gives x plus, taking exponential, x plus a into y divided by 1 minus a into y is equal to c. Or finally we can write this as x plus a into y is equal to c times 1 minus ay. And this is the general solution of the second problem. So thus we have solved the first and second problem. Now third and fourth problem, see, I will leave for you to solve. You should try third and fourth exactly in the similar way. It is easy. So we can separate the variable, shift this term, and then take 1 plus y on the left side and 1 minus x on the right side, and then integrate. Here also it is easy to separate the variable. So tan y term we don't want here, and here we don't want 1 minus e to the power x. So we can divide by the product of these two, or take this one side for dx, another side for dy, and then shift the terms. So then it will be easy to integrate after separating the variables. So the answer I have written here. You should check the answer. Try to solve these problems and check the answers. So this is we have studied variable separable form. The remaining forms we shall continue in the next lecture. Thank you.